Today's program is brought to you by the Programs and Education Committee, of which I'm the co-chair, Steve Penzella, a longtime head of that committee. We still appreciate Steve's efforts and benefit from his knowledge and dedication to BOMA. Today's program, as you know, Mass Timber Trends in Design, Engineering, and Construction, kind of the brainchild of Christian Heiner, who sits on the board, brought this, helped kind of champion this topic. Our two speakers today, William Silva is our Regional Director of Pre-Construction for Swinerton. His bio, quickly, is graduate of Oregon State with a BS in Construction Management, over 30 years of experience throughout the West Coast and Inland Northwest, having worked both in project development and self-performing heavy civil, concrete, and mass timber. William joined Swinerton in 2004 and returned to the Pacific Northwest in 2014. He is a passionate advocate for mass timber buildings with a knack of finding efficient and eloquent solutions to project challenges. Jason Tornquist, PE, professional engineer, structural engineer, is a senior vice president with WSP. Over 20 years in experience in structural engineering, and has, through his work there, become a leader in mass timber and engineering design, and has worked on a variety of mass timber projects. They'll both give a little bit more background, but please give me a hand and welcome them to the discussion.
Let's hope this works better than our experience with the screens, right?
Well, you know, I think that's part of public speaking, is to figure out the AV system to just heighten the adrenaline of the moment. So, and we're actually going to be on this end of the room. We brought some nice stools for everybody to look at as a focal point, but the clicker works from this end, so we're good. Anyway, excited to be here to talk to you about mass timber. I tell you, after being in the industry almost 35 years, it has brought a lot of reinvigoration to new solutions for buildings in the built environment. I do start with a warning label that when it comes to mass timber, I can talk to you for days. We're really going to try hard to finish a little bit early so that we can get some Q&A in. So hopefully there's some stimulating material, but also opportunity for follow-up. This is where we find the end of the room. There we go. People, not product. What I've found is that people are connected to wood. There's something really unique about the material that causes us to respond. For me personally, I love to use this as an icebreaker on projects when we kick it off. For me personally, I think about 4 generations in the timber industry before me. I think of my grandfather and his brother as young men in the 50s on a logging operation in Southern Oregon, and kind of what that means to me. And it really starts kind of a connection that seems to have come full circle in what we're doing in delivering mass timber buildings. But Jason?
The picture above my photo there is a photo I took back in 2016, and it's of a 4-acre lot that my wife and I absolutely fell in love with. 4 acres, fully timbered, surrounded by 1,000 acres of DNR forest. We bought the lot. 7 short years later, I'm excited to report we have practically finished our house, a world record for residential construction, but more importantly, we're still married, which is a shocker given the slow pace of our project. But I'm lucky enough to live and have my family surrounded by beautiful forest, and it's something that we both find really energizing, or all 4 of us find really energizing, and it's something that we've built our life around. So there's certainly a personal connection to wood and timber for not only me, but my family.
That's great. So as we, really it works. All right.
We're going to be just gradually moving around the corner throughout the presentation.
This is, there we go. A little bit about Swinerton. So Swinerton is a 135-year-old company. We have 20 divisions across the U.S., a little over 4,000 employees. But the reality is, the exciting part is being in the Northwest, having an office here in Boise, as well as in Spokane, Bellevue, and Portland. It's really allowed us to service the community. But since we're talking about mass timber, part of what is exciting also is From our first building 7 years ago, we've now completed over 25 buildings, mass timber buildings, have over 40 in design and construction across the US. And really are excited about what that means as this continues to be adopted both in code and opportunities. So we're going to talk through a number of trends, things that we're seeing in design and opportunities for different market sectors today.
And briefly about WSP, so huge engineering firm with over 50,000 staff globally and about 12,000 staff in the US. The buildings practice that focuses on the built environment that all of us look at is about 1,300 people in the US, so it's far more manageable in terms of size. And we're structural, mechanical, electrical, plumbing, fire protection engineers, as well as a number of other specialty practices. With respect to mass timber, we've got over 100 completed significant mass timber projects across the globe. A lot of those are in US, Canada, Scandinavia, and the UK, and about 50 in North America. Our firm was an early signatory to the Structural Engineers 2050 Challenge, which is a big part of why we get into mass timber. We can talk about that a little bit later if you'd like. And we've got an office here in Boise that our buildings team is led by Christian Heiner, the handsome fellow in the blue blazer back there. So, thanks very much.
All right, you get 2 for 1. So one of the things that I always take the opportunity to start with, and I think this is really critical to what has allowed mass timber to come into the mainstream, is about project teams. Let's face it, we live in a construction industry that is very siloed with very inefficient reactionary approaches, and that kind of represents the right end of the spectrum. What we really aspire to in mass timber is really coming up with what we call the silhouette table. And the silhouette table is where kind of owner, architect, and contractor, trade partners, and the jurisdiction come around a table where the table represents truth, trust, and transparency. And it's really allowed these better ideas to come forward, because we're going to talk a little bit today about complementary benefits and other things that help these projects really come to fruition and be effective in the built environment. And so I wanted to kind of lay that down as the foundation for just a really key factor of bringing people together. But also it takes that holistic approach of striking a balance, really looking at performance and quality against budget requirements and schedule requirements. It really kind of guides a lot of outcomes, and we're really talking about things earlier in the design process in a very collaborative way, where we're interacting and finding the project priorities oftentimes in schematic design and then working on them together for delivering a project to success. But why the move to mass timber? Aesthetic earns its prominence at the top because it's beautiful at the end of the day, and the space that you experience, it's very different. I've had clients walk through completed projects and just say it's like a breath of fresh air. And that gets a little touchy-feely, but for those of us on the technical side, there are a lot of other things to look at. So kind of created this lotus that really starts a conversation early about why mass timber might be adopted for a project. Structural efficiency, schedule efficiency, labor resources, availability for prefabricated systems, etc. It's light on its feet, so high cost foundations could be a consideration. These are all things that really you can tease out and understand associated with the delivery of a project. The 3 that come mainly to the forefront is a lot of times around environmental impact, aesthetics and market differentiation, and project cost and schedule. A lot of people like to talk about schedule because it can be, and oftentimes we start a project looking at how can we deliver the project 20% faster with a mass timber building. But it takes how you think about all of the building systems and how they come together. Aesthetics and market differentiation kind of dominate a lot of the people, the developers and others who bring mass timber buildings forward, because it's a very different product for what you experience within the space. But we also see a lot of people really wanting to understand where the materials come from. Like, very rarely do you build a concrete building and talk about where did the aggregate come from. But a lot of times in mass timber buildings, people want to know which forests did the trees come from? Do they come from our region? And I think that's important here in the Northwest, because we all kind of have that innate connection back to the forest and timber and the timber industry.
A little bit more on the why of mass timber. Biophilic design, we'll jump into the details of this a little bit more later, is a really powerful experience for users of a building, which can create market advantages for those who own or lease the building. William mentioned some of the potential for cost and schedule savings, and he'll give some more detail on that. But with respect to sustainability, some of the materials mass timber competes with, steel and concrete and CMU, are incredibly energy intensive to make, which means that there's a lot of carbon dioxide emissions associated with those materials. For example, where concrete is emitting 300 kilograms of CO2 per ton made, mass timber is actually sequestering 800 kilograms of CO2 per ton. So that forest life cycle, where you can actually take carbon dioxide from the atmosphere and sequester it in a building, is a really powerful commitment to sustainability, and something that moves the needle with respect to climate change. We've started to set the table a little bit about some of the basics and how you assemble a team for a mass timber project, but given that this is a pretty varied group, we thought it would be a missed opportunity if we didn't take a minute to talk about what mass timber actually is with respect to structural technology. At the most basic definition, it's essentially a kit of parts that's made of off-site fabricated heavy timber elements. And there's a couple different technologies that are used. The first is glulam timber. It's something that has been around for a long time. Many of you are probably familiar with it. You see it in a lot of buildings where you see laminated wood beams. That's glulam, very common construction practice. CLT, cross-laminated timber, is the next one over. And that's what a lot of people right now in the industry, when they hear mass timber, they think of CLT immediately. And that's made of basically alternating plies of what looks like 2x6. It results in a very strong shrinkage-resistant material. And because you're using smaller pieces of lumber, it can also help a lot with forest management. The manufacturers of CLT can harvest much smaller trees than they would for some other forest products, which helps with wildfire management and some other things. Mass plywood panel is another one, whereas CLT comes in basically nominal thicknesses. Mass plywood panel is a heavy panel assembled of plies of plywood, more or less. And because it's effectively totally custom, there are a lot of opportunities to machine and fabricate mass plywood panel into really anything that your architect or your design team can think of. The other three most common mass timber materials are DLT, which is on the left, dowel laminated timber, which is basically vertically oriented planks that are tied together with wooden dowels. Because of its all wood nature, DLT presents a lot of opportunities architecturally for different machined shapes. You can see in the picture there's some basically grooves routed into the bottom. That can be used for architectural advantage, or it can also be used to help manage acoustics in the space. A lot of designers want mass timber to remain totally exposed, which means no soft surfaces, no acoustic panels. So with DLT, you can route in grooves and actually insert acoustical material right into the product to help manage some of that noise. Nail laminated timber, not exactly a new product. I did a seismic retrofit of a school in Seattle that was about 105 years old, and while we were digging through a mechanical mezzanine, we found a 100-plus-year-old NLT deck. So they've been taking 2x lumber and nailing it together for as long as there have been a hammer and nails, but it's something that people think of as kind of a new and exciting product. And last, we can take glulam beams and basically rotate them onto their side and make planks. It's a competing product to DLT and NLT, also shrinkage resistant and very dependent on the glue and some other things. So, but it's another important product in our mass timber toolkit, I'd say. With respect to wood framing schemes, I wanted to take just a second to show how mass timber might compare to a typical or a competing steel or concrete building. From a structural standpoint, we usually live in about a 30 by 30 grid, which makes nice clear spans for building. It's very regular, very repeatable, and pretty well understood by kind of everybody in the building chain. Architects, engineers, owners, leasing agents, everybody kind of expects that 30 by 30 grid. You can get there with mass timber. It involves a couple of different framing elements. You can see in this picture we've got some large beams in one direction, some smaller beams in another direction, which can create a couple challenges. You can see there's some ductwork flying through that interstitial space in the foreground, which is great. It provides some opportunity for ducts. In the other direction, those building systems have to drop down by the depth of those beams, which can create kind of a cluttered ceiling space, and it can also drive a pretty thick structural cassette depth, which can be a challenge for a lot of reasons. One of the alternate systems is to eliminate those girders and go with a tighter grid spacing, which sometimes building owners can see as a challenge because you're reducing the kind of effective usable area of your building. But in the right setting, you can actually celebrate those columns and still make a really workable floor plan with a much more efficient mass timber system. There are also hybrid systems that bring steel and mass timber together. One system is Delta Beam, which is a proprietary steel beam. It's that inverted trapezoid you see on the right there. And that allows us to use beams with these planks that give you a nice clean soffit, still really rapid to erect, still very efficient, but it helps to preserve that larger bay size and that thinner floor-to-floor elevation, which again, from a development standpoint, can be really important.
So talking briefly about code, and I think this is the piece that has really allowed some innovation that is really carrying the market right now. Back in the 2009-2012 codes, that's where you started to first see CLT coming in and some exceptions for how CLT might be in the perimeter envelope. But in 2016, there was an ad hoc committee that started with ICC to study tall buildings and essentially mimic 3 buildings that were developed, 2 of which were delivered. One was called the Carbon 12 building in Portland. That was basically the model for what we call Type 4C. And Jason's going to talk a little bit about these code cycles. A building called Framework that was permitted in Portland but did not go forward for development challenges. And then UBC Brock Commons, which is an 18-story up in British Columbia. But through testing, it really allowed that to come in and be adopted by the IBC in 2019, and we saw jurisdictions start to adopt, allowing up to 18 stories with timber structures. A lot of fire studies went on, testing chamber fires that burn for 4 hours without fire protection to demonstrate the resiliency of this product. We'll talk a little bit more about fire, but the critical thing in this room is really that last square on the right, where in January of 22, just last year, Idaho recognized the tall wood count, the 2021 IBC code, allowing these structures to be built here locally. When we think about building strategies, a lot of people think, well, I couldn't build mass timber until the Type 4 code got adopted. But oftentimes, early buildings in mass timber were really delivered at a Type 3A or a Type 3B. Or a Type 5B. And really, there are code paths that are straightforward, that are easily understood for jurisdictions. The big thing is how it affects the ratings of the building. So it's kind of unusual, but a lot of times we're sitting at the table together, that silhouette table, and we're asking the question, what's the building type? We're really driving that conversation early because it really starts to inform the strategies for how to deliver the building. And if we can make it a non-rated building like a Type 3B or a Type 5B, you can see how that's kind of a baseline cost. And as you add the hour ratings in wood, basically you're adding thickness to the wood member. And so it adds $10 to $15 a square foot, depending on how many ratings come in, how many hours of fire resistive rating that you bring into the structure. So it's really, these strategies start to layer in to how we think about these buildings.
With respect to the construction types that William was just talking about, I wanted to give a real clear graphic that compares some of the allowable construction areas. So on the far right there, we're seeing a Type 4 heavy timber building that was allowed under the 2015 IBC. And you can see that's a height and a scale of building that most people kind of associate wood buildings with. You know, your low rise, fairly limited construction. The new tall wood code cycles introduced the 4A, B, and C, which respectively let you go to 18, 12, and what is it? 18. 9 stories. So that takes you from, 85 feet maximum height, which a lot of people think of as, like a podium style light frame building, up to, you're 18 stories. You're several 100,000 square feet. There are some code hoops you have to jump through to get there. There's protections that we'll talk about on the next slide with respect to how much wood you can have exposed. But these code cycles and these changes really allowed tall timber buildings to be competitive with steel and concrete, and really opened up and unlocked a new construction type for a lot of projects. Like I mentioned, there were some significant architectural impacts to going from Type 4C to Type 4B or A, and that really comes down to how much of the wood you can leave exposed. It goes from a place where you can leave all the mass timber exposed if you're in that 4C, and effectively none of your interior surfaces have to be covered at all. Where when you get a little bit taller, you have to cover a little bit more of the building. Taller still, you have to cover effectively all of your interior surfaces. So as William mentioned, that can have a really dramatic impact on not only the aesthetics and the feel of the building, but also on the cost of the building, because that's a lot more material that you need to bring in to be code compliant.
And the upcoming code revision, the 2024 IBC, allows even more exposure within the Type 4B, and so it's a real opportunity for how that will compete. Because at the Type 4A, when you're going up to 18 stories, you really don't see the wood. It's all covered by drywall. And so you really can reduce down, even allow more of the wood to come into the space.
And if we really wanted to geek out, there's also different fire protection requirements, things like that during construction, but way off into the weeds. With respect to lateral design, the current code that governs seismic forces and lateral design is ASCE 716. So presently there's no mass timber true lateral system allowed. There are a couple different options. You can use a mass timber lateral system if you have an amenable building official and you can basically prove equivalent performance. That's totally depends on the friendliness of your local building official. Sometimes it goes great, and sometimes you're just beating your head against the wall, quite frankly. So a lot of designers choose to actually use a non-mass timber lateral system, something that's more conventional. For the taller buildings, that almost always ends up being a concrete core. For the more mid-rise buildings, it's very common to see a steel brace frame system. BRBF is buckling restrained brace frame, a very resilient and flexible lateral system. The future code, ASCE 722, which will be codified in the next cycle, is actually going to provide provisions for CLT shear walls. The R and 3 and 4 are structural code implications. There still will be maximum height limitations. You can't go above 65 feet. You can't perforate or add windows into those shear walls, which is something us structural engineers have to deal with and will, I'm sure, have countless architectural arguments about. And frankly, in areas of high seismicity, Seattle, Portland, California, it still might be more cost effective to stick with those conventional lateral systems. But it'll at least be a tool we have to do full mass timber buildings and not rely on conventional systems.
So just a little bit more on lateral systems to give you a visual. Talking about concrete shear walls, steel buckling restraint brace frames, and then brace frames you could do as well when you're wind governed on the approach, which we're right on the edge here, here locally for consideration, but also those CLT shear walls. We see CLT shear walls coming in through, I like to say, SPIDWIZ 2021, so I sound cool, but to geeks. But
sound like an engineer, yeah.
Yeah, sound like an engineer for a second. But we've utilized that for two-story buildings, mass timber buildings like out in Bend, Oregon. It worked out really well there. We see great opportunity with that as we go further east and we kind of step off the Rockies and get to be more of a wind-governed design. The projects that are more cost-effective often are the buckling restraint brace frame. You can create a nice rhythm with the mass timber erection. If you do concrete, you can kind of see you really have to build the concrete shear walls all the way up. So when you talk about climbing shear walls, gang form, for a 4-story building, that sounds really odd because usually your breakover is like in a 12-story building. But the reality is the mass timber is so fast that you have to take the concrete ahead. We were involved in our sister company, Timber Lab, installed the Ascent Tower in Milwaukee, Wisconsin, which was 25 stories, 19 stories of mass timber over 6 stories of concrete. The concrete cores on that were 10 floors ahead of the mass timber when it started, but the mass timber still caught them before they reached the top of the tower. That's just how much faster it is. So you really have to think about speed of erection and how you bring this together because you're prefabricating so much offsite. The other thing is we talked about Type 3 as being a path forward, but the building envelope on a Type 3 building is a 2-hour rating. And so you have to think about how do you bring the structure within the enclosure. It brings a nice aesthetic in. This is an academic building that we did at OSU Cascades out in Bend that utilized that. And so you can see how having the columns within the space adds a bit, but it really has a cost savings component to it. The other thing that, again, I shocked my design friends when I started asking about occupancy and accessory uses and things like that, because again, a contractor, how often do they talk about that? but really coming up with strategies, how do we maintain that non-rated? If you remember the difference between a type 3B versus a 3A, that's an hour, that's $10 a square foot on the building. So if we can come up with ways to deal with assembly uses and really incorporate that in, we can get the AM&M going and really save money and really think about it. The other thing to think about is mass timber doesn't necessarily have all the UL assemblies that we're accustomed to in concrete and steel with shafts and other things. And so we get into engineering judgments. And that was a little more troubling at the beginning. But now that there's a book of details that are coming through, we're starting to see that be less of a roadblock to projects. But having access to that information is critical.
One thing I'll add to that as well is that really heightens the importance of early collaboration between disciplines. Whereas in traditional construction, if you need a pipe to penetrate your floor slab, somebody comes out, they core drill it, you find the UL rating that applies, you do some fire caulking, and boom, you're done. With mass timber, as William just mentioned, some of those details haven't existed yet, or those ratings haven't been approved yet. So you need to be really careful to coordinate those during the design process, so those holes can be fabricated into the assembly, and everybody can be on the same page of how that works. So just another reason to have a design team and a construction team that are integrated and collaborative.
So on this next slide, we have procurement considerations and really talking about supplier locations. So you see we're kind of right in the middle of a wood basket here locally. So a lot of the manufacturers are here, and we've kind of created an approach to take advantage of the different suppliers. Intentionally, I have two that have a red strike through. D.R. Johnson in Riddle, Oregon has dropped their CLT manufacturing, as well as Structureland, who's based in British Columbia, has stopped production in their Arkansas plant. So there are kind of still volatility in the supply chain, but there are enough suppliers that have continued to ramp up to provide the supply, but it's being aware of what those implications are. So as we look at suppliers, you also recognize that in CLT, well, CLT is really the workhorse of the industry in mass timber. There are a lot of different panel sizes, and you say, okay, that's nice, good to know, and you think about it like a sheet of plywood, but the reality is you're cutting this with a chainsaw, right, if you want to adjust it. So we really want to prefabricate off-site. The other thing to think about is if you go to a manufacturer and you work with them to optimize the structure, the reality is just a slight shift in base spacing can change the outcome of which manufacturer is more cost-effective. Because the manufacturers are trying to promote their product, they become a little bit biased on steering you towards what's most cost-effective for them. It's good to have kind of an agnostic approach to recognize that and work through that base spacing. And when you're talking about base spacing, that's something you're really working out at concept and schematic, right? So one of the things that we've done through our sister company, Timber Lab, is really took a look at kind of highlighting off of that silhouette table and really look at two things. One is looking at the overlap between the AHJs, the jurisdictions permitting, but looking at fire safety and structural together as being a key component. The other thing we identified were constraints and restrictions in the supply chain, and so we kind of focused on how we can augment teams through timber engineering, virtual construction, BD&C, BIM, however you want to call it, procurement, fabrication, prefabrication, and assembly. We kind of shifted from thinking about it as construction, thinking about it how we're assembling a kit of parts, and fabrication being drilling and cutting, prefabrication being adding hardware, where you're bringing a kit of parts to the site that basically erects like an erector set. I love the Lego erector set analogies that I get out of projects, but and what that does is it kind of responds to a lot of the manufacturers. So you get manufacturers that have different capacities and abilities. And so it's being able to kind of supplement that to open up more of the supply chain is kind of critical to how the projects get brought forward. And really talk about kind of integrating the manufacturers. And so up here is kind of an example of a number of projects where you can kind of see the approach to the timber engineering, whether it was the engineer of record or whether it was something that was supplemented through what we could add to the team. But through manufacturing, fabrication, prefabrication, assembly. But also the key thing is every one of these projects we're bringing forward now has a lot of innovation involved. And innovation takes a lot of additional effort by the project team. You know, it's a commitment from the owner. It's the design team working towards, you know, what creates the right outcomes for projects. The other is on BIM coordination. that BD&C element is so critical because we're integrating all of the building systems together with steel, timber together before the project ever comes to the site. And so all of the manufacturing has all of the drilling, cutting integrated into it. This is an example of a residential tower that we're finishing up at the end of the summer, which is the first Type 4C building built in the city of Seattle. But that prefabrication allowed all of those holes to be drilled, so you don't have to have an electrician or a plumber laying out hoping they're drilling in the right place. The holes are already there. They can run their pipe and basically deliver quicker in the field and safer and more efficiently. With mass timber, just like I highlighted on the concrete shear walls, the delivery of mass timber also contemplates that you're really starting that detailing early and you're making early commitments before you ever set foot on site. Fiber deposits and other things are critical for these buildings in order to bring the timber along efficiently. So making teams aware of those needs and constraints. But it's akin to like when we build tall steel buildings, having a mill order and placing the money for that in order to deliver the schedule. And then really working with the design team to talk about, what are the opportunities? What's an expensive cantilever in mass timber? What's a relatively free cantilever that you can do if you're on the strong axis of a project? If you're going to have ground floor experiences like retail and other things or parking components, how do those grids translate into the efficient structure like what Jason showed before, getting from a 30 by 30 grid roughly into, say, a 15 by 30 grid? So really thinking that through early on really provides the solutions where you're not trying to reverse engineer into a solution later in design, because at DD you're sunk. Contemplating that at schematic early in the design phase really allows you to come with a solution that will work. And then balancing big moves with efficiency. This is a community center in Hillsboro, Oregon, where it's a public agency, it's public money, the community is very interested, but how do you maintain the budget? And so, studying where the big moves are versus the efficient moves. The big moves were clear spanning the timber over the top of the gymnasium, creating the clear story that allowed natural light into the gymnasium, and the 18-foot cantilevers at the entry, looking at how those manifest. I mean, that's pretty impressive when you put your cardio machines right over the top of an 18-foot cantilever. It's something to contemplate. But every other aspect of that building had zero waste in it. The panel layout's 13.4 with a 40-foot panel, so that you exactly span on the beams, minimizing any waste associated with it. But if you can do that as a team and you kind of work that through at concept and schematic, early in the design phase, it really makes the solution work at the end of the day. I love these pregnant pauses for the clicker, so this is like amazing. I feel like if I keep getting closer, it gets better. Hey, so one of the things talked about prefabrication kit parts, really talking about how do we contrast these buildings that we deliver. Same site, poured-in-place concrete parking structure, 35 carpenters and ironworkers, 6 months, and the man hours associated. For 10% of the man hours associated, hitting a prefabricated approach for the mass timber building, that's the erection crew right up there. They put it up in 12 weeks. It was pretty amazing to watch the speed. People came by the site during mass timber and they're like, man, why are you guys shut down today? It's like, no, we're going full steam. It's all good. But it's exciting to see about that opportunity. But then you think, am I taking away jobs from the field? No, the reality is we're taking those jobs and we're putting them into a fabrication facility, in a warehouse where it's day in, day out, not subject to layoffs, but like more of a manufacturing scenario. So we're kind of just shifting our thinking and shifting our workforce. And I promised this earlier, complementary benefits, and I'll try to hit it quickly, but it's so exciting because it's a puzzle, and if you love puzzles, mass timber is for you, I'm just telling you. The reality is thinking about mechanical systems, envelope, daylight, and structure and how they come together. Jason alluded to this earlier. This is kind of a colonnade approach where you can see the ductwork and services kind of running down a corridor defined in the middle of a building. Talking about how that goes to mechanical systems, in this case a low energy system that utilizes mechanical units out at the perimeter under the windows, looking at how to optimize the percentage of glazing to balance the energy model for the building. And then at the end of the day, contemplating the daylight, because when you hit that grid, and you eliminate those girders. I mean, I remember the first project I was on, the architect said, there's no beam at the perimeter. Oh my gosh. And the glass immediately went all the way up to the deck. And so what you perceive is not the bottom of the beam. You perceive that CLT deck, and that daylight pours over the room. So here you are, no lights in the room, and sufficient daylight. The lights barely go on in this academic building, and they typically go on at night. And so you start talking about what this means relative to energy use and natural light in wood in the space. It's really exciting about how these spaces deliver through. And it's not limited to office buildings and academic buildings. We're seeing the opportunity, this is from that Heartwood project, the Type 4C in Seattle, to utilize it in multifamily and in hospitality to create opportunities. Again, with no girders, your services can run in the corridors, distribute into the units. Every tower you do in residential, 20 stories or not, you talk about, am I taking services to the perimeter or taking them vertical? Those are all strategies that continue to play out. And so it's exciting to see how those solutions come into play. And then looking at everything down to the details, like the connection details. Thinking about how, we get triple duty out of a connection. How does it both the beam connection, the column connection, and the pick point for the erection? So we're finding efficiencies for this kit of parts. It's like, getting creative with our Lego set, if you will. Looking at composite action. I think we could probably geek out on this, but you can stretch the cantilevers by adding screws at the edge, basically, to kind of stretch the cantilever for the CLT deck. Looking at this, which is a huge innovation for the first wood-to-wood 2-hour permitted connection. So this allows towers to go up because when you get into the Type 4, the structure has to have a 2-hour rating. What this does is through just embracing old woodworking techniques of mortise and tenon, you're allowed to then have this all-wood connection come together. The gray is what they call a fire tape. One of our engineers found this in Europe, but essentially that fire tape, were you to have a fire event in the building, that intumesces to 6 times its size and fills the voids. And so it allows this to be a dry connection that can be erected in any weather to allow that 2-hour fire rating to come together. And there's no steel in the connection. So it's saved $5 a square foot on the overall building cost by simplifying that connection and just embracing old woodworking techniques. The other innovation again, this came forward on the Heartwood project, but we've seen it now in several buildings, is MPP stairs, mass plywood panels. Jason talked about this material. It basically, you can see how the plank is in the image in the lower right, and we cut the tread and riser out of it, and it creates a really interesting face. We put a nosing on the edge of it, but you walk those stairs, and they're so solid, they feel like you're walking on concrete. It's not tinny like a pan-filled stair. So again, just exciting innovations that are happening throughout the industry. And then looking at site logistics and speed of construction, you look at the site and you say, yeah, average urban site. The reality is there's power lines on the right. The alley in the middle is that private alley that you have no access to. And there's a big tree on the corner that we want to save, even though there's an existing building. So there's like a 40-foot window that the whole building got erected through. And so bringing the mass timber on with the lightened, having the smaller crews, they can actually find parking. And then the speed of erection for how that went up. And as you look at the speed, one of the things that Jason alluded to is you have to think about how do you bring your enclosure with you. So we panelized the perimeter walls, and those were basically, the first floor took a day to put on, and after that it was a half a day to basically skin the perimeter of the project. That allows, because there's no reshores in mass timber, it allows the follow-on trades to immediately be in working underneath. And that really is what yields the speed on these projects. And then the other thing is I talked quickly about, you got to think about these really big panels and like how do you bring them to the site. So again, like City of Seattle, you can only bring in oversized loads in the middle of the day. And by the way, if it snows, there's limitations on the passes coming from Eastern Washington to the west. But also, you bring a 40-foot or a 60-foot panel through the city of Bend, they love roundabouts. Guess what? There's no path without going through a roundabout. I can tell you which 2 signs you have to take down to take a 60-foot panel through the city of Bend. So it's really thinking about how do you bring these materials to site. So it's really interesting because it kind of opens up and embraces a better understanding of the supply chain for all of our products, which is really, in the last 3 years, has helped us a lot. As we talk about fire, I'll geek words at the top, but the reality is, under old glue standards, wood basically burned, and every time you got to a glue line, the light gray line, it would start to accelerate the burn again. But the reality is, with the new glue standards, it behaves more like glue lam. And so we've been able with jurisdictions to talk through how do we use the char rate for glue lam for projects, and demonstrated how that burns. Because essentially what happens is that char, as it burns, it snuffs the fire. So you think about it, building a campfire, you don't throw the big log on first, right? Because that's kind of what happens with mass timber, is it basically protects it. That lower image on the lower left was actually a 4-hour burn in a chamber where they put in all the contents of an apartment and watch it burn with no fire protection, and demonstrate that the panel still has the structural capacity after that burn period. And then I mentioned Ascent, the 25-story, the 19 stories of wood over 6 stories of mass timber that was completed last summer. They pushed it even more because this did a performance-based design on fire, so rather than having to cover everything up in drywall, they were able to expose perimeter beams and columns, but they had to meet a rating of 3 hours on the columns, which had never been demonstrated before. And the connections and beams were at 2 hours, as well as the deck. That went through, we led the, get to the burn picture. This is what fire engineers love, is seeing burning things. But the reality is, the most telling of all of those tests was the 3-hour glue lamp column. And you can see how the fire essentially snuffed out on the image on the left. And on the right, you can see, carve all that char off. There's still a column in the middle that's supporting the deck above to the design loads. So it's a pretty interesting concept. And reality is, we've taken Seattle Fire Department through, we took the city of Hillsborough through, we've done this with a number of fire departments. We take them through these buildings and demonstrate this and show the fire capacity. They actually feel they're safer buildings than steel buildings. Because at the end of the day, the building is designed for the fire to essentially be not responded to and to go out and then still have the structural capacity. So it's amazing when you walk through with the fire department and lead them on that tour and just watch the realization in their eyes.
To wrap things up and set the table for some questions, we wanted to highlight, where does mass timber actually have synergy with development? And there's a few key types of projects. One, projects that can take advantage of biophilia and the natural aesthetic of timber construction. Like we talked about, wood makes people feel good. People have a connection to wood. So those projects where that exposed timber is important from a development standpoint, interior design standpoint, those are great candidates for mass timber. Where speed of construction is important. Whether it's because the rainy season is long or your client has got some very aggressive schedule to open their project. Mass timber buildings can be erected really fast, which can bring a lot of advantages over competing construction types. Or where a building needs to be light. If you've got really poor soils and you don't want to spend a bunch of money on an expensive foundation system, or if you're adding vertically to an existing building. We were working on a 7-story concrete existing biotech building in Seattle, and the owner's pro forma considered adding another 7 stories. If we would have done that or proposed doing it with concrete, it would have been a very expensive upgrade project. We said, let's do this out of mass timber. We could add 7 stories with no structural upgrades to the columns or the foundation. Unfortunately, they sold the building before we could move forward, so you can't win them all. But where you need to keep a lightweight building, mass timber is a great solution. Other focus or synergies are where you need to really sell the benefits of timber to your occupants. I'm not an organizational psychologist or a doctor, but there are a lot of physical and wellness benefits associated with mass timber. Lower blood pressure, lower heart rate, increased ability to concentrate. Like we said, people do really well in wood buildings, and that's something that can be really powerful, whether you're retaining the building yourself or developing it to sell. We'd love to tell you that every project is well suited for mass timber, but the reality is there are some headwinds against the use and adoption of mass timber in the industry. One, we mentioned that right now, until the next code cycle comes through, lateral force resisting systems are somewhat limited. We know we're going to get there, but right now for areas of high seismicity, tall buildings, that can push you to more conventional systems. Mass timber, it's fantastic in that it's fabricated to extremely tight tolerances, but when you have close integration with other trades, that can cause problems. That's always been a sore subject when you get to a concrete guy versus a steel guy. I've worked on projects where your anchor bolts are set to a concrete tolerance. The steel guys try to come on and drop a base plate, and it doesn't fit. And everybody's just pointing fingers at each other because they have manufactured to their own specific tolerances. Mass timber, with as tight as their tolerances are, if you don't have the right team in place, that can exacerbate that issue. Also, each mass timber subcontractor is a little different. Different panels, different trades crews. So like William has talked about, I think for the majority of this presentation, early integration of the right team is critically important. Cost is still a little bit of a headwind. Mass timber costs have been becoming increasingly more competitive with traditional materials. And when the right design techniques are used, mass timber can actually be extremely competitive against conventional systems. Right now, there are cost estimators that, when they don't understand a system and they see risk, that risk shows up in additional contingency in your budget, which can be a challenge for any project, especially with how expensive things are right now. The labor force is still a little bit limited with skilled tradespeople who really know mass timber. That's getting better every day, so we're confident that we can work through that. And then again, mass timber is still considered to many people a new or a novel technology. So sometimes you have to handhold your building official a little bit. You have to work with your design team a little bit more to make sure that early modeling study is taken care of. And sometimes insurers, sorry, I'm gonna pound on you for a second. Insurers who don't understand or maybe aren't as familiar with the risks of mass timber construction, you can sometimes see that as an increased premium when compared to some other building systems. So give us a break. Heightening the anticipation here.
No, that's fine. Just wanted to make sure we preserve some time for Q&A, and hopefully we gave you a lot to think about here. Like I said, I can talk for another couple of days too, so we're all good. Any questions from the audience relative? Yeah, right here in front.
So considering how fewer man hours are needed on site for that scope, do you see the project you did, if you notice any difference in terms of like safety incidents?
Yeah, we find and promote that it's a much safer environment. If you think about it, when we did our first office building, we were thinking about 13 feet off the ground, drilling a beam. If you had a glue-in beam, would you drill a beam off a ladder for your mains, right? But the reality is it comes out with the hole already there, so it's basically more about running pipe. And so there's a lot of things that are inherent in that with a reduced crew size, but there's a lot of thought about the strategy. How do we utilize tie-offs because you have a strong material and all of that, but we're seeing a lot better safety associated with it for sure.
You're also reducing hot work. I mean, light frame construction, you got plumbers and electricians running around with hole saws and sawzalls, doing God knows what. That's an accident waiting to happen. So inherently, there's a lot of safety.
Thanks for limiting the audience on God knows what, because most people say that about contractors. Other questions? Yes.
I'm curious about transportation costs, right? Because we have, in the Northwest, sure, it probably makes a lot more sense than somewhere where, just because we have such a high concentration of those manufacturers, how much does that play a role?
It definitely does play a role. That's part of why we look at the national map when we look at it. We're also looking at rail for goods movement as well, because that's a great opportunity for that. You just need to think a lot about handling of material. I think on the West Coast, you can see the impact of the 5 corridor for distributing from the wood basket, as well as some of our freeways here and truck distribution. But we have a fabrication facility in Portland that really services our region. But we just opened one up in South Carolina and Greenville to service the balance, kind of the mid-Atlantic, southeast, that's focused on southern yellow pine. Because the 3 species you'll typically hear are Douglas fir, spruce pine fir, and southern yellow pine as being kind of the workhorses of the industry. There is research going on right now with white fir, which comes out of kind of the Oregon-California border. Sierra Pacific's very invested in that, but it's exciting to see how it relates to species. Again, everybody wants to tie it back to the tree as opposed to the river they pulled their aggregate from. So
There was another question right here.
Yeah, I just wanted to ask about the volume of the decrease in high picture fire sprinklers. Isn't that like give rise to more water supply needed than the conventional building?
We don't see a hazard change in the fire protection, so it's not, we're not seeing it impact that as such.
Maybe in the early days when you had to do an alternative methods and materials approach and maybe use a deluge fire protection system before the tall wood codification came about, but now
Right.
it's pretty comparable to other systems.
And Type 4 HT used to have prohibitions on concealed space, but now those are being lifted and you have other code paths that don't require additional sprinkler heads. Well, we have our contact info up on the board, and feel free to reach out if you have follow-up questions. Also point out Bruce, Nick, and Josh over here, kind of in the front. Happy to hit them up. They're right here at 5th and Grove, so you can drop in on them and just pop quiz them with any questions. See how fast they text.
Or do the same to Christian at next month's BOMA event.
That's right. Just wear the blue braid, wear the blue blazer again so that everybody can spot you. All right?
Well, thanks, gentlemen.
Great presentation, you guys.